inequality. So here's the first one. A linear inequality in one variable is an inequality that can be written in the form ax plus b greater than 0, where a and b are real numbers, with a not equal to 0, any of the symbols greater than or equal to, less than, and less than or equal to may also be used. So as a summary, we're using these symbols here. So I'll make a summary for the symbols. Less than and greater than. In the number line, we're going to have the empty circle. And for the notation, the set interval notation, we're using the parenthesis. And then for less than or equal to and greater than or equal to, we have a shaded circle. And then it's a square bracket for the set interval notation. Okay, so let's have our first example. Negative 3x plus 5 greater than negative 7. So remember, we're in inequality. In inequality, you have plenty of answers. Unlike we use the linear equation before, you have one answer only for solving for x. Right now we have plenty of answers. So we have to express our answers in set interval notation. So solving for x here, we have to do the same thing as we did in the past, isolating our x. So I have to move 5 to the right side, it becomes a negative. And then I will calculate negative 7 minus 5, that's negative 12. And then I have to isolate my x here by dividing negative 3 on both sides of the inequality. So x here, now there's a rule when you're dividing a negative or multiplying a negative, it actually reverses the symbol. So instead of greater than, you will get the less than here. And this would be our answer. In the number line, this can be drawn like this. This is negative infinity here, infinity. We have 0, 1, 2, 3, 4. And then we have less than, so we have to use the empty circle for 4. And it is less than, so you can actually think about the symbol less than as like an arrowhead pointing to the left. So our answer now here, it's an empty circle, and then it's going to the left. and that would be our x values. So you can say that our x values here could be a 3, could be a 2, 1, or any negative numbers. So the lowest we can have is negative infinity. Okay, I'll put a different symbol also. You can also use, you have a number line here, you have negative infinity and infinity, and then just copy this, and um, instead of the open circle, we can use the parenthesis to symbolize. Let's use a different color, okay, to symbolize the solution. So the x should be here. So either of the two for the number line. So we can use that one. Okay, and for set interval notation, you can write this as negative infinity going to 4 in parentheses, and you can have that as your final answer. And that's the one that's going to be in the solution set. Okay, so next problem. So here's the other problem. Negative 2 less than 5 plus 3x less than 20. Okay, so we have here the three-part inequality. So you have two less than symbols. Going to circle this out. So the first one is here and the second is here. So if you want to do this simultaneously, you can do that also. And the easy way to do this is just using the same way as we did on the first example. So we can have this as two solutions. So I can write this as negative 2. I'll split this into 2. And then I have to solve for my x here now. Okay, so I will move 5 to the left side. Becomes a negative 5 less than 3x. Then I have to divide this by 3 and also 3 on the other side. So I will get negative 7 over 3 less than x. Now we're dividing positive here, so we're not changing or reversing the symbol. So before we reverse that because we were dividing a negative number. So when you divide a negative number or multiply a negative number, the symbol will reverse. So that's the only the difference between solving inequality and an ordinary equation, like a linear equation. Now, that's our answer here. And on the other side, we have to split that into 5 plus 3x less than 20. And then solve for x. So solving for x, I have to move 5 to the right side. So it becomes minus 5. And then divide 3. And we're dividing a positive number, so the less than will not be affected. Still a less than. So that would be 15 because that's 20 minus 5. 15 divided by 3, it's a 5. So that would be the other solution. So in a number line, um, we're going to plot this in a number line. And that would be a 0 here, negative infinity, and infinity over here. Okay, so negative 1. We have a negative 2 here, negative 3. So we're looking at an empty circle. So somewhere here for, let's label that in a different color, negative 7 over 3. And it says negative 7 over 3 less than x. So it's going to the right. And the other value, it's 5. So we're looking at 1, 2, 3, 4, 5. And that's a less than. So we have an empty circle. And the value for that, it's negative 5. So it's actually x less than 5, so it's going to the left. So our answer would mean this one. This is your x here. I'll just shade this part. So this is our x. So that's the solution. In set interval notation, that would mean open circle means parenthesis, right? Negative 7 over 3, comma, and to the right it's 5. And it's an open circle, so that should be in parentheses also. So this is our final answer for the solution set in set interval notation. Okay, let me switch my screen to um, quadratic inequality. So before going to the quadratic inequality, um, I'll show you first the table. So here's the table for the symbols that we're trying to summarize. So we have the open interval, and you can see in the open interval, you're using parenthesis here. So this is the set interval notation. And going to the right, it's actually positive infinity. So if you have the number line, think about the smallest you can have to the side. To the left side, it's negative infinity. And to the right side, it's positive infinity. So since that is a parenthesis, so we have to use actually open circle or parenthesis to symbolize that. So you can also use something like this, an open circle, okay, instead of the parenthesis. So on the second column, this is the set builder notation. So set builder, and the common notation that we're using for this, it's set interval notation. So there are two notations that you can use actually. So it's just the common one, it's using set interval notation. Okay. For the square bracket, you can also use the circle with a shaded one or a shaded circle to replace the square bracket. So that's the symbol. So again, what we're doing from the previous slide, we summarize this symbol less than, greater than. We use the open circle, and then the parenthesis for less than or equal to and greater than or equal to. We use the shaded circle or the square bracket. So if I'm going to mark that, you can see from the symbol we're using greater than here. So that's why we're using this 2. We're using greater than or equal to. That's why we're using this shaded circle and the square bracket. Okay. And then you can have the closed interval. So closed interval means you have this square bracket and that's the middle part of the number line you're looking at. The disjoint one, it's actually pointing to the left and pointing to the right. So that's how we call disjoint interval. And all real numbers, it means that your solutions can be anything in the number line. So that would be all real numbers. And some textbook has the symbol big R for all real numbers. So still this is in set builder for the second column and set interval for the third column. So those are the two notations that we're using in math. Okay, so let's go to quadratic inequalities. So we learned about quadratic equation before, but instead of an equal sign, we have now a less than or inequality. It could be greater than, it could be less than or equal to, or greater than or equal to. So those are the symbols that replaces our equal sign before. And we still have the same format. It's ax squared plus bx plus c in this case. Okay, so let's try an example using quadratic inequality. So switch our screen, and here's the example. X squared minus x minus 12 less than 0. Okay, now remember, think about quadratic equation. We have three ways to solve quadratic equations: by factoring, by completing the squares. So completing square, and the last one using quadratic formula. So you can still apply this method here by quadratic formula. So by factoring, by completing the square, and by quadratic formula. So here we can factor this out. So this is factorable. So you can have the trial and error factoring. And then think about this as a quadratic equation. So you can change the less than into an equal sign, okay, for the moment. And then you can actually get the values for x. So what your goal here is just finding the value for x. So x squared has these factors, x times x, and negative 12 has 12 times -1. We have -12 times 1, and we have -4 times 3, and the reverse of that one would be 4 times -3, and we still have 6 times -2, and -6 times +2. Still, you're getting 12. So now you're looking at the middle term, which is -x, so that would be -1. Which of this set of factors, when you add, it gives you a -1. So you're looking at this one, -4 and 3. So that's the pair that we have to choose. Again, -4 plus 3, that's a -1. That gives us the middle term. So I'll use -4 here and plus 3 on the other side. So you can always check by multiplying the inner terms and add that to the outer terms. So it will give you the middle term, which is the -x here. So that's how you check. Then you apply the zero factor property, which is x minus 4, the first factor, set that to 0, and the other one, x plus 3 equal to 0. And then just solve for x. X is equal to 4. By moving -4 to the right side, it becomes a positive. And the other one, by moving 3 from left to right, becomes a -3. So now that's not our solution yet. We still have to do additional actually ways to actually find the exact solution by having the number line and having the test value. So we have to test whether there are three parts of the number line, whether it's on the left, the middle, and on the right of those values we're looking at. Okay, so number line, going to draw the number line, and we're going to have 0 at the middle, and then -1, -2, -3 is here. +4, 1, 2, 3, 4. 4 is here. And then um, we're looking at the symbol. The symbol now it's less than, so it means we have to use the empty circle. So empty circle here and empty circle here. So we divide actually the number line into three parts. So this is our three regions of the number line. Okay, so let's put the label. This is -infinity here. Going to the right is +infinity. Okay, so we have our -4 here, and we have +5 here. Okay, so we have those three regions. So on the left of -3, that's region A. Region B is at the middle with 0. And on the right of 4, that would be our region C. And from there, we have to test the value, so we will know which of those would be the solution. Okay, so let's try. and uh, having that value, let's say this is the test now, so we're testing it. So let's say our x it's actually -4. So if our x is -4, you will have -4 here, power of 2 minus -4 minus 12 less than 0. Okay, so we will get 16 here, and then plus 4 minus 12 less than 0. So we have 16 plus 4 is 20, minus 12 is 8. Is 8 less than 0? The answer is false. So false. So it means that we don't have that in region A. So it's not on region A. So we can test region B. So region B actually is x. You can assign any value along region B. You can have +1, -1, or 0. 0 is easier to plug in. So we'll try x is equal to 0. So if that is 0, then when we plug in using the original equation, 0 power 2 minus 0 minus 12, then less than 0. So everything is 0 on the first two terms, and you have a -12 less than 0. The answer is true. So we found that now. So it's over here, it's true. So it means that our x, it's over here. So this is our x, and this is our solution. You can also test C, and obviously when you test C, region C, that would be false. But we already find that's at the middle. So when you write this out, actually, you will have this answer, parenthesis -3 because that's an empty circle, and then comma, and you have 4, and then still parenthesis. And this is our answer in the solution set in set interval notation. Okay, so I have to go back to the quadratic inequality. How did we come up with this? So we have different steps. So you can see step 1, solve the corresponding quadratic equation. That's what we did. In step 2, identify the intervals determined by the solutions of the equations. So we have to create the number line. And then step 3, you have to use the test value. So we're just testing it. Where's exactly the location of our uh, solution? So is it on region A, region B, or region C? So we have 3 parts of the number line that we're trying to test. But if you actually found it on one of the 3, then you can make a decision. So you may or you may not test other regions also. So to save time. Okay, so that's the rule. So let's go back to that rule again one more time and see if you can actually memorize that one. Okay, next we're going to a rational inequality. So this is the last part of this inequalities. So this is solving a rational inequality. Step one, rewrite the inequality if necessary so that 0 is on one side and there is a single fraction on the other side. So think about it. The key thing here is a single fraction on one side. So if you don't have a single fraction, you have multiple. You have other terms like a whole number. Then you have to get rid of that to make it a single fraction. So for step one. Step two, determine the values that will cause either the numerator or the denominator of the rational expression to equal to 0. So you have to split. You have to take out the numerator and put it to 0 and do the same thing for the denominator and put that in 0. In condition, you have a single fraction, okay, on that side. Then the last step, step 3, use a test value. So we always use this test value. So that's from the quadratic inequality also. We use the test value. Remember to divide the number line into 3 regions. Region A, region B, and region C. Okay, in order for you to find the right interval. Okay, so let's have an example. So this is for rational inequality. Okay, so example 5 over x plus 4 greater than or equal to 1. Okay, so now you have to think about the steps in order for you to find the solution here. So as you can see, there is a 1 on the right side. You have to move that to the left side of the equation. Okay, again, we have a 1. Move that to the left side. Let's just use the same color. Okay, just 5 over x plus 4 here minus 1. Moving 1 from right to left. You'll get a 0 now to the right side. And then finding the LCD, that would be 5 over x plus 4 minus, you have your LCD, x plus 4. So that would be x plus 4 also on the top that you have to multiply. So you will have that now. Okay, so LCD again is x plus 4. So that's in between x plus 4 and 1. So remember there is a 1 at the bottom of the whole number here. So you're looking at x plus 4 and 1. So between the two, it's x plus 4. It's our LCD. So LCD here, it's x plus 4. We have 5 here. We multiply this sign, minus sign, to the two terms x and 4. So that would be minus x minus 4 greater than or equal to 0. And then you combine like terms. So 5 minus 4, it's a 1. So we have 1 minus x over x plus 4. greater than or equal to 0. And then the next step is, remember we have a single fraction now. So looking at the left side, we have a single fraction. This one here is a single fraction. So we can actually set the numerator equal to 0 according to the rule, and set also the bottom, which is the denominator, equal to 0. So we can actually do that. You have 1 minus x is equal to 0, and the other one is x plus 4 equal to 0. And then you have to solve for x. So 1 is equal to x, or x is equal to 1. So that would be the answer for the first one. And then x here is equal to negative 4. We're just moving forward from left to right, becomes a negative. So we have those answers. And then we have to create the number line so we can test. So value 1 and negative 4 is not the solution yet. So we have the negative infinity here, and you have the positive infinity on the other side. You have a 0 at the middle. 1 is here, negative 4, negative 1, negative 2, negative 3, negative 4 is here. And you have to look at the symbol. The symbol, going back to the original problem, it's greater than or equal to. So you're supposed to have a shaded circle. So it's like that for 1. So, but you have to check 1, you plug that in, still defined, because that's 1 plus 4. You're looking at right here. We're looking at x plus 4, the bottom part. So we will know if you can apply that. Now we're supposed to put a shaded circle for negative 4, but when you plug in negative 4 to here again, x plus 4, it gives you a 0. 5 over 0, it's undefined, so you cannot use that one or that value as part of your solution. So that should be an empty circle instead of a shaded circle. So that should be an empty circle. Again, because it's undefined when you plug in negative 4. So here's the actually 3 regions. So this is region A, region B, and region C. And we have to apply the test again to make it sure where's the location of the solution. So we can test first the middle part. If you're looking at the middle part, it's easier because you have a value 0 in that region. So that's easier to test. Okay. And you can have like x is equal to 0. And then you use the original problem. So that would be 5 over 0 plus 4 greater than or equal to 1 for the original problem. So just plugging in the value for x, which is 0, as our test value. So now we can evaluate 0 plus 4 is 4. So 5 over 4, is it greater than or equal to 1? And the answer is true, right? The answer is true. So if that is true, then we found it right away. So it's at the middle because that's true. So here's our x. So if you want to test other region, like region C, for example, you can actually put a value. But of course, that would be false as expected. So let's say the value there would be in that region, you can have a 2 there. So we can try x is equal to 2, x is equal to 2, so that should be 5 over 2 plus 4. And this is greater or equal to 1. So that's 5 over 6 because 2 plus 4 is 6. So 5 over 6 greater than or equal to 1. The answer is false. So obviously that's false as our answer. So false here, and then false also in region A. You can test that also by plugging in probably -5. Of course, that would be false. So what do you think is our final answer here? Our final answer would be the middle part. And we can express that into set interval notation. So that would be an empty circle, that's a parenthesis, and then a -4, comma, 1 and a square bracket for 1 because that's a shaded circle. And here's our final answer. So in the solution set, it's a -4 or parenthesis -4 comma 1 square bracket. And that's the final answer. Okay, so think about how are you going to test and what are the rules to follow for rational inequality, quadratic inequality, and linear inequality. But think about the summary of the symbols. Remember the empty circle, the closed circle, the parenthesis, and the square bracket. Those are the symbols that we're using. And there are two notations here. It's the set interval notation. So most of our answers, like this one, the final answer here, it's in set interval notation, and the other one, it's set Bellver notation.